Welcome back to the deep dive. Now, right up front, we need to say that all the sources for this deep dive come directly from the weekly newsletter from AnySilicon.com. Our mission today is a fast-track look at the biggest moves in semiconductors, really focusing on what's driving the industry right now.
Yeah, and if you kind of connect the dots from their newsletter, you see this sharp split forming.
A split.
Definitely. On one side, you have this extreme, absolute focus on speed for AI, pure performance. But on the other, there's this critical push for resilience and depth security, for specialized chips in cars or defense.
That makes a lot of sense. So let's start with that speed race. We hear constantly that we're hitting a wall with electrical signals over copper. Where do you even begin to squeeze out more performance?
Well, it really starts at the source memory access. Bernice's just launched the first Gen 6 DDR5 clock driver.
Okay, what does that mean in real terms?
It means we're getting almost 10% faster memory access than the previous top-end. You have to feed those hungry AI chips faster.
But even with faster memory, if the signaling itself is the problem, you have to pivot, right? To light, optical interconnects.
Exactly. And the newsletter highlighted this huge partnership between GUC and Ayar Labs to integrate co-packaged optics, or CPO.
And the numbers they're talking about are just staggering.
Oh, they're aiming for optical interfaces over 100 terabits per second. I mean, that's not an incremental step. That completely redefines what a computing cluster is.
And foundries are making big moves based on this.
They are. Look at GlobalFoundries. They acquired Advanced Micro Foundry specifically to build out their silicon photonics portfolio. They're making a clear bet that they can become the biggest pure-play silicon photonics foundry out there.
That feels like a huge risk, though. They're betting on photonics while giants like TSMC are all in on, 3 nanometer and below.
It's a calculated pivot. They're betting the next big wave isn't just about smaller transistors, it's about solving that interconnect bottleneck. And this focus on speed is everywhere. QuickLogic gave their eFPGA hard IP to cheapest for a data center ASIC.
So they can spin up new product variants faster.
Incredibly fast. It's all about speed, speed, speed.
Okay, so that's the bleeding edge. But let's flip that coin. Let's talk about the systems where failure is just not an option. Reliability over everything.
Right. And automotive is the perfect example. Mixel integrated ASIL-B-compliant MIPI DPHY IPs into Indy's radar processors.
And for anyone who doesn't live and breathe those standards, ASIL-B is about functional safety.
It is. It's a guarantee. It means the chip is certified for things like collision detection. These systems simply have to work, period.
And if you think cars are a challenge, what about space?
The ultimate reliability test. GlobalFoundries again, this time partnering with BAE Systems. They're using their 12LP tech in New York to build radiation-hardened chips. You can't just send a technician to fix a glitch in orbit.
It's not just about current reliability, though. It's about future threats.
That's the next frontier. AnySilicon got £5 million in UK funding for a secure processor. And the key part is it has a post-quantum cryptography accelerator.
So they're literally building in defenses against quantum computers that don't even exist yet.
Yes. They're making future cybersecurity a foundational part of the silicon design today. It's a huge shift in thinking.
And what about the lifespan of these chips? The newsletter mentioned Proteantex and Akiana.
Yeah, they're integrating hardware IP monitoring directly into RASCV processors. The goal isn't just to work at launch, it's about ensuring reliability and performance over, say, a decade in the field.
So with all this specialization, how is the overall manufacturing landscape holding up?
Well, GlobalFoundries is seeing it pay off. They reported more growth in automotive and communications. That focus is working for them.
But the giants are going in a different direction.
A very different direction.
Yeah.
TSMC and Samsung are significantly cutting back their 200mm or 8-inch foundry operations. TSMC is talking about a 30% cut long-term.
Why?
They're just doubling down on advanced 300mm tech. The cost per chip on those older, smaller wafers, it just doesn't make sense for the high-volume stuff anymore.
So tying this all together, what's the big takeaway for you?
Look, the industry is being pulled hard in two opposite directions. You have the frenetic, incredibly expensive race for AI speed on one end, and on the other, this fundamental, deep need for embedded security and resilience in everything else we all rely on.
And that leaves us with one final thought for you to chew on. ASML's CEO, Christophe Fouquet, recently committed to staying in the Netherlands, but at the same time, he started demanding regulatory reform and a more competitive environment from the Dutch government.
So think about this. If the single most critical equipment supplier in the entire world is making public demands for a stable environment, What does that tell you about the future fragility or the required security of all our future supply chains, both at home and around the world?
Something to keep in mind. Until next time.